There is a missing power of x though, right? Did you catch that? So remember, oh no. It's so unfortunate when you don't realize that, sorry. So don't forget we're dividing by x minus 2, so that means we put negative 2 inside here. That's the number we're using because we have to use the 0 of the function. But careful here, we have 1, negative 3, but there's no x to the third, so we need a 0, 8, negative 9, and then 27. I think you're less likely to make that silly of a mistake if you're doing long division when there's a missing power of x, just because then you kind of just notice things don't line up. This one, there's kind of no checking it. It's just kind of you're blindly doing the math they're asking you to do. So, all right. Multiply, add, multiply, add. Is it 1? Is that what you mean? What did I do wrong?
I got it's not 13, it's 15.
Thank you. Did you? Alright, there we go. Sorry. You get negative 3?
Yeah.
Okay, there's our remainder. Okay. Like I said, without like going back and like redoing it and checking your work, that's probably the only thing I don't like about synthetic division is there's nothing to tell me if that makes sense as an answer. So negative 3, like I said, it could have been 1 and I've been like, oh, that sounds fine. Like, I mean, so without having like the math behind it, it's tough to check your work with synthetic division. It's really easy to make a silly mistake, like I did a quick addition error, and that caused everything else to be wrong beyond there. So that's kind of what makes it tough. So being comfortable with synthetic and long division, we'll use both. All right, so talking about something being a factor of a polynomial. So it says show that x minus 2 is a factor. A factor means it divides in evenly. So what would that mean the remainder would be? 0. So to be a factor, the remainder must be 0. So if I divide these two and it's a factor, the remainder is going to be 0. Now, I think we mentioned this yesterday that a 0 of the polynomial is when the polynomial equals 0. So in this case, like a 0 of the polynomial would be when that factor equals 0. So when the factors of our equation equals 0. So if x minus 2 is a factor, then that means 2 would be a 0 of that polynomial. So it says show that it is. And the way we'd show that is we'd show it has a remainder of 0. So again, you could use whatever method you want, scientific, synthetic or long division. Probably most of us agree that I think synthetic it's probably quicker in the long run. Again, I like it, but at the same time, the long division is a little bit better in terms of for me to be able to check my work. So like on a test, I'd probably rather do long division because I have time, but when I'm just trying to get through something quickly, I probably would choose synthetic, but it's up to you. What's up? Yeah?
Well, how it's written down, looks like the factors would be divided by the equation itself, or is that how it's supposed to be done?
Not necessarily. I mean, that works in this case.
Divided by factors, or is it,
So,
what order is it supposed to go?
well, it's saying that this is a factor, just like if I'd say like 3 is a factor of 12.
Oh, wait, so it's equal.
So So I take 12 and divide by 3. So I'm taking this and I'm dividing by x minus 2. Is that true? Okay?
Then why is it reading like it's the factors are being divided by the equation?
I guess I don't understand your question.
The order of this.
The order it's written?
Yes.
Again, because that's how we write it. We say,
No. We'll find the definition is like shouldn't the equation's factors, the words themselves be swapped? They're like
no, that's not divide, that's and or. That's a and or line. Sorry, that's not, like, so he thought that was a division mark. Sorry, I didn't understand your question. And or, yeah, sorry.
Oh,
I know, math is confusing because they use the same symbols we use in English for other things. So, so we want to show that this is a factor. The way we're going to do that is we're going to check that 2 has a remainder of 0. So again, we use the opposite sign of what we see. So we're going to put 2 in here. And then we're going to do our synthetic division. And I don't have any missing powers of x, so I don't have to worry about that. So since it's a remainder of 0, we would say that x minus 2 is a factor. So that means, yes, it's a factor. That's enough to show that. Now, same thing needs to happen on this next one. Now, again, this might be one you decide to do long division. I know it's a pretty long problem, but if you don't like it when we have to solve this, so we move the 2 over and divide by 3. So 2/3 would be our little number that we're dividing in here. I don't see any missing powers of x. So we divide by 3, multiply by 2, so I get 2. I get 4. I get negative 10, right?
Mm-hmm.
I'm like doubting everything. I've made enough mistakes today to make me nervous with my math skills. And then I multiply here and I get a negative 2.
Yes.
Yay, thank you. And so there's a remainder of 0. Now this one, I do want to remind you guys, if we were actually trying to do long division for this, what do we still need to remember to do?
Divide by 3.
Divide by 3. So we do that on this step, but it doesn't need, like, it doesn't want to know what the quotient is, so we don't really need that. The remainder of 0 is just to show that it's a factor. So once it has remainder of 0, that's all we need in this case, but if we were actually trying to find the solution, we wouldn't want to forget to divide that by 3. Okay? All right.
That's so funny.
So flip the page over when you guys are ready.
We always like look
We're at the same time. Like I'll just like look over here. I just don't look over there.
I thought you guys were saying, why do you always do that when I was here and I say break at the same time?
Oh my gosh.
Let's go outside.
It's 47 outside.
Yeah.
It's cold.
Yep. Yeah, let's go outside.
It's not freezing.
I wrestled outside today.
Yeah, I didn't wrestle.
Sit your butt
Here,
down.
we're gonna finish these and
Yeah.
then we'll go
Oh,
outside.
Gary
got in a fight at least.
Really?
It was playful wrestling.
Who had to break it up?
Miss Wohlers.
Nuh-uh, I broke myself.
And no one recorded it?
I should have.
Yeah, no one recorded it. This never happens
I had to break up a fight at homecoming.
Wait, what?
Between who?
It wasn't a real fight.
You were in a fight?
Yeah, I was boxing.
Wait, there was a fight at home.
Did you
There
win?
was freshmen that were,
It was.
This year?
I was there.
Wait, this year?
it wasn't a real fight. They were egging Carson on.
What?
Egging Carson on.
No, we weren't.
Oh, yeah, I know about that actually.
Adler was playing Carson.
I like walk outside and like Carson's like wrestling someone, like, and I was like, oh my god.
Just go home. Take it.
I just went and grabbed Mr. Donahue because I didn't want to deal with it at that point.
I said I was tired of this.
He's the problem.
Me?
Tyler is the problem.
Okay.
Garrett's also the problem.
Which
No,
it
it
was
was-
like multiple towers.
It was freshman Tyler and then
Phone him in.
Tyler Sherman.
Okay.
They were fighting.
Oh wait, there was someone.
I was fighting
It
Tyler
was
Sherman.
John.
All right, guys. So,
I-
okay, guys.
He was older than me.
All right. So, there's a little statement here. Didn't want you guys to have to try and write it out, but we still need to talk about it. It says if you know a value c is a zero of the function, then when you divide it by x minus c, so when you divide it by that factor, the solution, the quotient, is also a zero of the function. So I'm going to show you guys how we're going to use that to help us. So if I know x equals -1 is a zero, that means that x plus 1 is a factor. Does that make sense? So x minus 1 is a zero, then x plus 1 is a factor. That's one of the factors. They're giving us a factor. They want us to find the rest of the zeros based off of knowing that. So what we can do is we can basically divide that out, and hopefully we should be able to solve what's left over. So we're going to use, again, synthetic here. Because this is a pretty ugly equation right now. I wouldn't know how to solve that. There's not like a way to factor this to solve it. Oops, sorry. I knew there should be a negative somewhere and I wasn't finding it. So it did what we expected. We got a zero for our remainder. But what's left over should also be a zero of the function, or a factor of the function. So what we have left over, this is our remainder, this is our constant, this is our x, this is our x squared. They want us to find the other zeros, or the other zero of the function. So what we have left is this. I want to know when this equals 0. How would I do that? Yeah, you can factor it. You can use that 2 sets of parentheses factoring. Now, since there's a number in the front, the 6, nothing nicely comes out of, like, you can't like divide the 6 out. So you either have to do the guess and check, or you can use this type of factoring that I've shown you guys. That's where I multiply that first and last term together. And I want to add to get that middle number. -10, +3. So now we're ready to factor, so this should be factorable. Sorry, I didn't leave you guys enough room on this one. 2x. Now remember, I want these to match, but I still need to factor something out. So it already is 3x minus 5, so I'm just going to take out a +1, kind of as a little placeholder. So we're down to 2 factors that we can set each of those equal to 0 and find the factors that also equal 0. So I solve this one, I get a -1/2, right? And then I also get a +5/3.
Yes.
But don't forget that we also had a solution at the start, which was also -1. So we actually have 3 answers to this problem. And before we move on to the next one, I do want to point out something else that we can do with this. Is if they asked us to factor something like this f of x, this is actually a really good way to factor if you don't know how to factor. Like if you look at this, that's not factorable the way it is. So what we can do instead is we can rewrite this now with the factors we found. So we have these two. But there's also this factor. So this is this polynomial factored with 3 terms. So kind of trying to see like these connections between these, that those gives us zeros, they give us factors, yep.
So which one's the answer?
So what were they asking us? Use us to find the other zeros.
So, okay.
Just those two, yeah. But if they but I don't want to like just limit you to like that's all we have to do in this problem. So they asked you to find all the zeros, we'd want to include the -1. If they asked you to factor this into 3 terms, we'd want to write what I have up there in like the darker red. So I just want you guys to kind of notice the difference between those two and the similarities.
You can just use that to make this fun.
Sure, Cash. All right, now this time they're giving us 2 factors. So probably should have left you a little bit more space, but hopefully it'll be okay. They're giving us 2 zeros in the function. So we basically going to kind of do them one at a time. So I'm going to start with either 5 or 1, probably just 5 because it's there first. So again, they're giving us one of the zeros, which is also a factor. Now I'm anticipating that my remainder is going to be 0, right? Because if it's a 0, the function, that means it goes into. It should be a remainder of 0. Oh my gosh, what do I do with just like rewriting numbers? I forgot where I was. Okay. So, what do you think we should do now? It's remainder of 0, which is what we wanted. But, yeah, what do you think?
Do we like make the
What's that?
Do we like make the equation?
You can make the equation. I'm actually going to tell you not to do that. There's a reason why. But making the equation, so that'd be like x to the third minus 13x plus minus 12. Rather than doing that, let's just keep going with this. What else do we know? -1. So rather than like rewriting this back into an equation and then having to take all the numbers out again, what I'm going to do is I'm kind of just going to change over to now make this a -1. So what that's going to allow me to do is it's going to kind of allow me to divide this again without having to do a ton of work. Now what Stone said isn't wrong. It just, you don't really need to do that. Like it's not really going to get us anywhere. We have to divide it anyway. We're just going to keep dividing. So, and just so you know, the order you divide these in doesn't matter. If you divide it by the -1 first and then the 5, it would still work. So, now, careful though. We don't want to use their remainder. So we're stopping like a little bit short there. Because this is our remainder. This is our constant, this is our x, this is our x squared. So we're left with even though it took us a little bit more time to get here, it was a lot easier. Yeah.
Should be -12.
Yeah, that's what I was gonna say.
Yes, thank you. That would have caused issues in a second, so thanks for saying something. I don't know, it's Friday. My brain's on Friday
It's
apparently.
alright. And that's what we need. Great.
You're on Garrett's, Team Garrett.
Here, we're literally halfway, like over halfway.
Or we just stay
They're
right
almost
now.
done. There's literally
Well, and Paige has to leave, and then we have the whole lesson done for Paige.
Yeah, but Paige
Which
should
would be
look
awesome.
at
Paige needs a break.
it. Obviously, Paige should look at the schedule whatever
Let's talk about Paige's priorities.
My bad.
Math.
Yeah, honestly.
Alright. Now this type of factoring is the easier way. I know already it's going to be x times x. We at least need to finish this problem, even if we're arguing about it right here. Alright, we want to multiply to negative 12 as opposed to what I had, and then add to negative 1. Negative 4 and positive 3, yep. And then to solve that, we set each of those equal to 0. So we also get 4 and negative 3. Yay.
So does that mean that there's 4 zeros? in the-
Yeah, so this one actually has 4 zeros. So it has these two, the 5 and negative 1, bless you.
Bless you.
And that leads us very nicely into our last part.
What's the
What's
last
your taking
one?
break
Which is
before?
that little night.
The graph.
That little thing.
Yeah, the little graph. Yeah, squiggle.